If you've ever written code that shows pages of results, then there are two things that might be causing incorrect results and poor performance in your query. I'll explain both of them in this video. The way to do pagination, or showing a page of results such as from a search or a list of records, is done slightly differently in each database vendor. In MySQL, you use a combination of the limit and offset keywords. Offset defines where to start or how many rows to skip, and limit defines how many results to show. For example, to show the third page of records where each page has 10 records, you would write limit 10 offset 20. In Postgres, you can use the same limit and offset keywords, or you can use offset and fetch. The offset and fetch clause works in the same way. To show the third page of results, you would write offset 20 rows, fetch next 10 rows only. In Oracle and SQL Server, you would use this offset and fetch concept as well. So what's the issue with using this? There are two issues, but they can be solved. The first issue relates to performance. If you've got a small set of data, your pagination query may perform pretty well. Here's an example of a query that shows pages of data. We can run the query and see the results. But once the table starts growing and you get more data, your query will probably start slowing down. This may happen even if you have indexes on columns in the join clauses and the where clause. The reason the query starts to slow down is because of the way the database finds the pages of data. The query has an order by clause, so you know what order the results are in and how to determine the pages to fetch. Every time a page is fetched, whether it's page 2 or 20 or 200, the database needs to sort the rows and then determine the rows to return for this page. This operation can be slow. Here is an execution plan of a query that is used for pagination. I won't go into too much detail on how to read this plan, as I'll save that for another video. For this query, we can see that the database reads the customer table and the cust order table, performs a hash step, then performs a hash inner join to combine the data from both tables. It then sorts the data and performs the limiting on it. To find the cost, we'll have to see the text version of the explain plan, which we can do by adding explain to the start of the query. We can see there is a cost here of 522, which is an arbitrary number that indicates the effort involved of running the query. But there's a way to speed it up. Also, I've demonstrated this concept on a Postgres database, but the concepts apply to many other SQL vendors. You can create an index on the columns included in the order by clause. To do this, first you find the columns included in the order by clause. This could be one column or multiple columns. Next, create an index on these columns using the create index command. Run the command and the index is created. Now we can check the execution plan again for the same query and see that it has changed. We can see there is a PK customer on the left, which is the primary key of the table. We also see our index of IDX CO date, which is the index we just created. There's a nested loop inner join and then a limit keyword. Importantly, there is no sort step here because of our new index. We can run and explain for this query to see the cost, which is 38. This is much better than the cost of 522 before. We can run the query and see the results. So the first problem of performance can be resolved by adding an index that covers the columns in your order by clause. Let's look at the second problem with pagination queries. Let's say we have this query here that shows the first page of results. We show all records ordered by this date here. We can run the query and see the results here. We have 10 rows showing. If we want to see the second page, we can change the query like this. We run the query and the second page of results is shown. However, there is a risk with this query. The data is ordered by this date field only. A record may appear in position 11 when ordered by date, meaning it doesn't show on page 1. When we run the query for page 2, this same record may appear in position 25, meaning it's not on page 2 either. That may be okay, as we might see it on page 3. Or even worse, it could appear in position 8, meaning it would show on page 1 during our query for page 2. This means it didn't appear in the page 1 query when we ran it, and now doesn't appear in the page 2 query. The row is never shown. The reason for this is that the database doesn't show the data in the same order every time if there are multiple rows that meet the same criteria. It may seem like it does, but the only way to guarantee it is with an order by clause. We already have an order by. How can we improve it to avoid this issue? We need to do something called deterministic ordering, which is just another way of saying we need to update the order by clause so that it includes a unique value in the criteria, so it always orders by the same thing every time. An easy way to do this is to add the primary key to the order by clause. We can order by the date here and then the ID of the table. This means that even if a row has the same date, it will always appear in the same position in the results, because the second ordering criteria is the ID. If you don't have an ID, for example you're using a query that doesn't need the ID, then choose another unique field. Or consider adding the ID into the query so that it can be ordered. That's how you can avoid the issue of missing records or duplicate records in your pagination queries, by adding a unique column to your order by clause. Pagination queries in SQL are useful, but there are two things to consider when you write them to make them effective. Ensure you add an index on your columns in the order by clause to improve performance, and ensure your order by clause has a unique column in it. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you liked this video, consider subscribing to my channel. Thanks for watching.